Okay, hi there, friends. This is another update on our eruption going on in Iceland. Today is Sunday, December 1st. I'm Geology Professor Shawn Willsey. Thanks for joining me. It is about 10 a.m. here, Mountain Standard Time, about 5 p.m. over in Iceland. And it's been a good 5 days or so since I did my last update. I was on vacation last week with the family over the Thanksgiving holiday, so I appreciate your patience. I was keeping track of the eruption as best I could, especially thanks to Amanda Joe for providing me information so I could more or less keep track of things while I was away. But let's go ahead and get to it. As you can see here, the eruption is continuing. Here's our live webcam footage showing the eruption taking place. We have one primary vent that's active, this northerly vent near Stora Stokfeld. The lava flow that was feeding that westward uh, lava that was moving towards the Blue Lagoon and the power plant, that has since died down. That flow is cooling slowly, but it's no longer advancing further to the west. The lava coming out of this cone here is mainly moving off to the east, running into the hills at Fagradalsfjall, and just pooling in an area. So this flow in particular poses no threat or risk right now. So it's a good place for the eruption to be going at this location and at this time. Let's run you through exactly where the flow field map is currently. So maybe make that a little bit bigger. Oops, I got too many things open there. Um, there we go. So you can see the map here, Blue Lagoon Power Plant, the defensive berms, which have done a great job of keeping lava out of this very critical area. The flow field from this last eruption on November 20th is shown in the purple. The other shades of purple are older flows. And this is where our vent is that's erupting right now. So this is our primary vent. As we've seen with these other eruptions, the fissure eventually subsides and concentrates down into one primary vent. And that's what we have here. And so this vent's been active for a little over a week now, I suppose, since the eruption began on the 20th. And who knows how much longer it'll go, but it's mainly feeding these flows out here to the east, running into these hills here. And so there's quite a bit of real estate here for lava to accumulate and pile up. And none of the lava in this area is expected to flow substantially to the south or to the north, where we might see roadways and other bits of infrastructure that might be at risk at all. Of course, we did have another vent further to the south that was feeding this flow here, but that vent since died down. So that's the good news. That's our flow field map so far. The Met Office did have a update that came out. I guess this was on Saturday. They'll probably put out another one tomorrow, Monday, once the work week gets going. They say evidence of magma continuing to flow from depth into the accumulation zone beneath Svartsengi. We'll look at the GPS here in a second to see if that's jives pretty well. Unhealthy gas pollution. So basically, the winds has been blowing out of the northwest and blowing a lot of the gas down into this area here. You can hike, or you were able to hike into these older lava fields and where the eruption took place in 2021, 2023. But right now, the gas is going into that region, and so it's not advised that folks go there. And in fact, I would guess it's actually closed at this point. Eruption has continued with constant activity. Lava flow from the active craters now mostly to the southeast, which is what we talked about there. So not a whole lot there. There's our map that we just looked at there. By way of, I guess we do have a couple things from this here. Sorry. Let's see. We've got a volume of about 47 million cubic meters. Lava bed on average is about 5 meters thick. And this is the second largest eruption of the ones that have happened in this region on the Sunuk crater row since December 2023. So the amount of lava that's erupted from this particular area during this time in November 20th being the initiation date, that's the second largest so far. Pretty interesting. And then they have a comparison here of, sorry, I actually didn't see this earlier, so now I've got to kind of digest it in real time. Yeah, this is just I guess this is the size of each eruption, December 2023. Oh, it's the duration, how many days. Okay, so remember our March to May eruption went on. That was chugging along for over 50 days. You can see how quick the December, January, February eruptions were. And then if I get myself out of the way down here, you can see that the most recent one here, the 7th eruption here in November, has gone on now for approximately 10 days or so. So that shows the duration of the eruption. And this one here, I'm assuming, shows the volume. Yeah, millions of cubic meters of lava, December, January, February, the March through May eruption, the late May into June eruption, the August 22nd eruption, and then this one here in November. So it's just barely gone past the May eruption in terms of total volume of lava that it's erupted. So we'll have to see where this goes. I kind of doubt it'll exceed the December event, but we'll have to see moving forward. Yeah, deformation measurements continue to show small changes between days, indicate that the inflow into the magma zone, storage zone. Let's see, average flow from the eruption was about 11 cubic meters per second. Based on SO2 measurements, it's estimated lava flow is about 7 to 8 cubic meters per second. Yeah, so we're about 5 to 10 cubic meters per second in terms of actually outflow, in terms of lava coming out of the ground through the vents. So sorry, I actually didn't see those down there, so I didn't prepare that. So that's the Met Office update. There also, excuse me, hit the microphone there. There also is some information from some of the preliminary analyses of the geochemistry in the rock. So actually collecting the lava samples and seeing what the chemistry looks like there. As you might expect, the chemistry of the lava from this November 20th eruption largely mirrors that of the previous events. And so this just kind of acknowledges that. But it's a good idea to always check that, right? You might be getting magma coming up from a different source. We might get indications about how long the residence time is for the magma. But in this case, it's pretty unremarkable, I suppose, in that it's very similar to the May to June eruptive event and the August event in terms of magnesium concentrations and other chemical parameters that they look at there. So, so pretty interesting there. I'll put that link in the video description, as I always do. The GPS data is not totally conclusive, but I think suggestive. So here's the uplift preceding the eruption on November 20th. Here's the eruption, and this specific GPS site showing downdrop, so or downward movement in the elevation. That's caused by the magma erupting from the subsurface up onto the surface. So it causes the elevation of the station to move downward. And it trended downwards for a couple of days. Then you can see it actually flattening out. And the next thing to look for will be, do we see a clear upward trend here? I expect we will see that. I see no reason to believe that the magma influx from deep, the thing that's actually feeding the eruption, is actually dwindling. If it stays stable, that might suggest that the magma inflow from the deeper magma storage zone and the magma outflow through the vent are pretty stable. But I think we'll probably see, if I had to make a guess, I would guess that we'll probably see the outflow at the surface possibly dwindle. It might take a while, it might be slow, and we should see a resumption of this slight inflationary trend here. But we'll have to see moving forward over the next few days and weeks to come. Earthquakes, pretty boring. Again, not much happening here earthquake-wise, so that's to be expected when you have a clear conduit system that's open and magma's moving through that system unobstructed, getting to the surface. So we shouldn't expect any big jumps in the earthquake data coming anytime soon. Our good friend Bruce Gardner put together some information with the earthquakes. Let me pull up his email he sent me. Here we go, so I can read it to you. I've even got this one annotated now, so thank you to Bruce for putting this together. But this shows starting back on February of this past year, February 23rd, and going up to more or less today or late November, the different cycles of, this is the GPS data here. So here's the GPS data going up. The March 16th eruption, you can see how far it down drops. And he has 3 different stations here. The blue, red, and orange lines are 3 different GPS stations. They all pretty much track the same way, although it's slightly different elevations themselves. Then you can see inflation resuming, and that culminated in the May 29th eruption. So everything drops back down. A little hiccup here in the data. Everything coming back up, exceeding that elevation that was required for that eruption. And then we finally had the August 22nd eruption. Everything drops back down. And then this sort of slow burn here and this buildup to the November 20th eruption, which interestingly was at an elevation, GPS elevation, lower, slightly lower than what the threshold was reached at for the August 22nd eruption. So that's pretty interesting that we were able to get this eruption occurring. Usually we'd seen this trend, as you can see here, where each subsequent eruption required a higher level of inflation, a higher level of the GPS station in order to trigger the eruption. And we did not see that here with the November 20th eruption. So that'll be interesting if that holds true moving forward. But nice job there, and just plotting up all the data. And one interesting thing he said here was how much, let's see, what did he say here? And how the November drop has been slightly less than the August. So how much this has dropped down is less than what we saw with the August eruption. Now we know, of course, because we just looked at the GPS data, that this tracks back up, so these trends don't continue downward. So more was, presumably there was more of an elevation drop in the August eruption than in the one we're seeing here. He's got one more, I think two more graphs actually, maybe a couple more. So this is looking at earthquakes, and this is going back again to the same time period from late February up to today. Here's the March 2nd, he has March 3rd, March 2nd, March 3rd, whatever day, intrusion. So that was magma moving through the subsurface, but not actually erupting. Then earthquakes picking back up, and then the eruption on March 16th, plots right here. Things drop back down as the eruption's taking place. And remember, that eruption went on for, I think, several weeks. And then earthquakes building back up as we go into May. And then that culminating with the May 29th eruption. Earthquakes drop back down quickly. Now we're into June and July. And then we get this buildup. As the system becomes pressurized, rocks are being forced to break and fracture. And then that culminates in the August 22nd eruption. Things drop back down. But interestingly, notice there's no buildup here. And he annotates that here. There wasn't, all of these eruptions had a buildup or an increase in the frequency of earthquakes preceding the eruptive event. And we did not see that here at all. No marked increase in earthquake activity prior to this November 20th eruption. And indeed, the November 20th eruption took place with very few earthquakes needed. I just now realize I'm not blocking it. There you go, you guys can see that okay. So the November 20th eruption, a bit of an anomaly. A little different behavior, came sooner than we thought, was preceded by fewer earthquakes than we had seen with other eruptions. And even the day of the eruption was brought with fewer earthquakes than we'd seen in the past. Next graph he has here shows, get my email back open so I can see it. This shows, so this goes from August through, so this is just mainly the August event, hourly earthquakes. So he's got a title here for me. Thank you. August 22nd eruption. So this is earthquakes per day. And you can see, not a lot of earthquakes. Then it ramps up very quickly around that time frame. Yeah, so this is, 820. Yeah, this is just a few days or so before. I guess this is hourly earthquakes. Each bar is a time frame of a few hours or so. But you can see it quickly ramping up on the day of the eruption and then quickly dropping back down. And I think remember what this one looks like as I show you the next one, because this is going to take the November lead up and as a comparison. So again, look at how few earthquakes there were on the November 20th eruption. There's the eruption, the little spike in earthquake activity, but look at how few there were leading up to it. Again, here's the November data, and there's the August data, and here's the November data. So quite a contrast between those two. So thanks to Bruce for sending that along. Very helpful. So the main thing that's gone on with this spatter cone, this vent that's still active, and many folks have had questions about it. And I want to show you the behavior here. So what we have is a spatter cone, but actually has two vents. I guess I'd call this one on the left is sort of the primary one, because I think that's where it's erupting most often. But it seems to have this oscillating behavior where it's erupting from one vent, then this one will die down, this one will pick back up, this one will pick up and be the primary vent for maybe a few minutes, maybe 10 minutes or so, and then this one will die back down and it'll switch back to this one. And what I've done here is grabbed a webcam image, and I'm hoping I can just show you this by kind of skipping forward. So notice this left side vent is the primary vent, and then as we skip forward 5 seconds or so, what we'll see is that the lava effusion rate, the rate at which lava is erupting here, the activity level, if you will, is going to die down, and we're going to see this right side vent, which right now is just outgassing. You don't see any lava there immediately. It's going to pick up a little bit. And let's see. Yeah, let's move it forward just a skosh. So you can now see that the left side's shut down, the right side's picking up, and then the right side picks up even more, becomes more active. Lava starts spilling out of its crater. Left side's pretty much dead at this point. And then this moving forward, we go forward just a little bit further, then it's going to switch back over. So this goes on for several minutes until we get something about in here. So now you can see the left side starting to pick up. We move forward, the left side will pick up even more, the right side will shut down. And there you go. Then the left side is the primary vent, and the right side is now more or less inactive. Interesting behavior. And I wish I had a hard, good answer. I have sent an email to I will send an email to Mike Poland and see if he has any insights into this as well. So the question would be, why are we having this sort of oscillating behavior between these two vents? First of all, I think it's one connected vent. I think that the conduits to each one of these are right next to each other. So it stands to reason that there is not two separate pipes or conduits feeding each one of these. It's a connected system, but then as you get closer to the surface, there's some sort of disconnect or something, and then something favors one side versus another. Remember too that what's primarily feeding and driving these eruptions of lava at the surface to form these spatter cones is, yes, lava, but more importantly, the thing that's driving and propelling the lava upwards is the gases. And so those gases are what are propelling. Remember, the lava is dense and heavy. It should be not at the surface. The thing that's actually brought it to the surface is, one, it's hot enough that it's molten, it's lava, but two, it has so much gas pressure and gas content to it that actually gives it the buoyancy to rise and then erupt at the surface. And so it may be that we're seeing some sort of change there in pulsating activity. I tried to draw a real simple sketch here that might show it a bit. And I don't think it looks anything like this, but so we have, one vent and the other. Here's the primary vent, the one that was on the left side, the secondary one. And it could be that, it's coming out here, but then as it's pulsing, maybe something's causing it to change vents. And for a while I was thinking it was supply surge and pulses, but that doesn't quite make sense, because if you were having an increased influx of lava, wouldn't you see both of them going off at the same time if there was more pressure in the system? And instead what we see is, yeah, they overlap a little bit, but one takes over while one shuts down. It erupts for a period of time, and then it switches back to the other one. And so the only thing I could find was to help explain this, until I wrap my head around it maybe a little bit more and spend a little more time thinking about it, is a paper, and I wasn't able to get the whole thing, but there was a 2018 paper looking in Hawaii about cyclic lava effusion. And all I was able to get here is that they saw pulses at the vent that were caused by shallow outgassing changes. So basically, in the shallow levels, there were changes in the amount of gases coming out of the lava, and that seemed to be what was causing sort of this pulsating behavior. But I'm not even sure pulsating is the right term, because I think their study probably involved higher lava effusion rates, and then it would slow down, and then it would ramp up, and then it would slow down. And that's not what we're seeing here in Iceland. We're actually seeing a switching mechanism. It's almost like there's a valve or something in the subsurface that's allowing one vent to go off, and then it switches to the adjacent vent. And so I wish I had some hard answers for you here. All I can say is I'll look into it a little bit more. I'll talk to some colleagues and see if they've seen something like this before. So it's nothing, it's of interest, I suppose, because it's kind of, but it's nothing that, portends something dramatic going on in the system. It's just kind of an interesting relationship here where one vent goes off, and then it's the other one, and then it's back to this one, and then it's on to this one. And so if you just kind of toggle back and forth, you can see it switching sides. And so I don't know if that's blockage in the system. There could be something that's blocking it periodically, but it's doing it so episodically that it's pretty interesting. So anyhow, so really cool and interesting thing. A lot of people watching the webcams have been very consumed and interested in it. And I've only been able to see it a little bit because I was on vacation last week, but I have at least witnessed it. I don't have any recollection of anything happening like that before. And so I don't have a good explanation, but we'll try to hunt that together and see if we can figure out exactly what's going on there. So, okay, so just to kind of round out this update, a couple news stories here. Thanks to Amanda Joe for sending these to me. Nice story here about, again, the second largest eruption in the series. And we kind of saw that with the Met Office update. Blue Lagoon was hoping to open this past Friday, but they're still working out all the logistics of getting folks in there. So while there's no lava headed towards the Blue Lagoon currently, their parking lot's been covered by lava. One of the main roadways has been covered. And so they're probably just getting all everything in place so that they can get those visitors safely into the facility in a organized way. So story there about that. And then finally, they are working on the new roadway. So they are already beginning to that north-south road out of Grindavik that goes by the Blue Lagoon and the power plant. This is even a couple days old, but they are already working to reestablish that roadway. And usually it takes a week or two after the lava stops flowing for them to reestablish that. But they become quite good at just getting in there right after the lava flows, especially on the margins where it's cool, and start moving things around. Pretty incredible, though. There's still a lot of gas in that lava, so I'm sure the workers have safety equipment and stuff. Pretty incredible they're able to do that quickly. So shout out to the Icelandic workers that are able to make that happen. Pretty incredible. Okay, so that's our update for today. Hopefully this was helpful and you enjoyed it. I'll continue to look into the fluctuating vents at the spatter cone moving forward. Probably do another update here midweek or so of this next week, first week in December. Thanks again for all your help and your support, and might be doing some drone flights with Nature Eye as well over the eruption area. So look for those, possibly some live streams along with the regular content. So thanks again. Have a great day, and we'll see you later.